Good morning, students. I am your new chemistry teacher, Prajisha. Okay, now onwards, I will be teaching you chemistry. So today we are going to learn about atoms and molecules. Already that chapter has started, I know. So we will be doing this chapter from molecules. Okay, so let us start from molecules. So what is a molecule? Molecule, it is the smallest particle of an element or a compound that is capable of independent existence and has all the properties of that compound. Okay, if you're taking element, if you take oxygen cylinder, suppose inside the oxygen cylinder, full of that cylinder should consist of oxygen molecule. The smallest particle in oxygen cylinder is oxygen molecule, and all the oxygen molecule is having what? Independent existence also. They are stable, and all the oxygen molecule is having the same properties of oxygen gas. Okay, so that is what they are saying. It is the smallest particle of an element. Or a compound. If you are taking a compound, like if we are taking a glass of water, it consists of full of H2O molecule. Okay, and this all H2O molecule are stable also. At the same time, all the H2O molecule are having the same properties of water. Okay, so that is what they are explaining. Smallest particle of an element or a compound that is capable of independent existence. That must be stable. Okay, that molecule must be stable and has all the properties of that compound. Okay, if you're taking water, all the water molecules present inside is having the same property of water. Okay, now let us see the difference between element and compound in details. Okay, what is an element and what is a compound? Actually, element means it consists of only one type of particle. For example, if you take oxygen, we were saying, right? Oxygen, if you are taking, oxygen is having only oxygen atom inside that. Only one type of atom is present inside that. Another example, if you are taking bromine, it consists of only bromine atom inside that. So element means it consists of only one type of atom. No other atom should be present inside that. If you're taking a copper rod or a gold rod, if you're taking copper rod, full copper rod is consisting of a copper atom. So that is why copper is called an element. But what about compound? If you're telling about compound, there is a difference. Okay, if suppose water, if you're taking, this is an example for a compound. It consists of a combination of elements. Different type of elements should be there. Okay, always a compound consists of more than one type of element. Okay, hydrogen is one element, oxygen is a different element. Okay, so they are combining chemically and we are getting a compound. Okay, so always we will be representing the element using a symbol. We know that all the elements are represented in the periodic table using symbol. If I am telling hydrogen, write the symbol, you will immediately write hydrogen is H. Okay, nitrogen, if I am telling N, like that. We have a symbol for representing the element, but in order to represent the compound, we have formula. We are using formula to represent the compound, like H2O is a compound and carbon dioxide, CO2. This is a formula of representing a compound. Okay, so we will represent a compound using formula. We will represent the element using the symbols. Okay, and if you cannot cut oxygen into nitrogen, you cannot convert oxygen into different element, or you cannot cut it into different elements. Okay, so we cannot break down an element, but we can break down a compound. If you are going to break down chemically this water molecule, you'll get hydrogen, one element, and oxygen, another element. Okay, so we can break down compound, but we cannot break down element. Okay, next thing is we can easily identify an element from its atomic number. If I am telling an element with an atomic number 20, you will easily see in the periodic table which is that element. Oh, that is calcium, like that. Okay, so from the atomic number we can easily identify an element, but we cannot identify a compound from the atomic number. We will name a compound based on its bonding. If it is having different type of bonding, based on that we are identifying a compound, that you will learn in the higher classes. Okay, now let us see element in detail. Okay, so there are we know that there are two type we will represent element using atom of an element and molecule of an element, right? Sometimes we will represent element like atom of element, or sometime molecule of an element. What is the difference between these two terms? So there is a difference between these two terms. Atom of an element means it's like hydrogen. This is atom of hydrogen element, or atom of oxygen element. Okay, it is not combined, so that is called atom of an element. If you take molecule of an element, how it will come? It will be combined. Molecule of an element should be combined, like H2, O2. These are example for molecule of element, Cl2. These are combined. But what is atom of chlorine? It will be represented like Cl. That is the difference. Okay, now from the picture, how can we identify an element and a compound? Let us see that also. If you take this particular picture, we can understand that element, look at the element, only one type of particles are there. If you look at the compound, you can see more than one type of elements are present inside that. Okay. And now let us see another term that is called atomicity. What is atomicity? Very easy. Atomicity means the number of atoms present in a molecule. Okay. If I'm writing Cl2, if I ask how many atoms are present in Cl2 molecule, you can easily tell 2. Okay. So 2 is the atomicity. Here. So let us see some example of that. Look here, argon, helium, these are noble gases. Okay, they are always in represented like monoatomic. They will not combine because they are already stable. Okay, so argon, helium, these all are always alone, so that they are called monoatomic. Only one atom inside, right? But if we are taking oxygen, hydrogen, nitrogen, and chlorine, all of this will be combined. Always it will be O2, H2, N2, Cl2, like that. So each of these molecule consists of 2 atoms. So these all are diatomic. Inside the molecule, 2 atoms are there. So that is why they are diatomic. If you take phosphorus, phosphorus has 4 atoms inside the molecule. So this is called a tetraatomic. Okay, this is called a tetraatomic. If there are more than 4 atoms in a molecule, then they are called polyatomic. For example, the case of sulfur. If you are taking sulfur, sulfur has 8 atoms inside the molecule, so that it is called a polyatomic. There, and all the metal we will be representing like monoatomic only. Okay, we cannot represent sodium as Na2. Always we will be representing the metal as Na, iron, Fe, aluminium, Al, copper, Cu. So all the metal will be representing as monoatomic only. Okay, so this is atomicity, very simple. You take the molecule and look at the number of atoms present inside that. That is its atomicity. Okay. Now let us learn another topic. That is, in your textbook, you can see this type of a box inside that. So what is that? This compound we already discussed. It consists of more than one element inside that. So if you are taking example of water, H2O, right? The ratio of the element inside that is 2:1. Very easily we can understand 2 hydrogen is combining with 1 oxygen. But if you are taking the ratio of mass, okay, hydrogen, the mass is 1 and oxygen mass is 16. Okay, since there are 2 hydrogen, the mass should be 1 into 2. So if you are writing the ratio, how we can write 2:16. So if you simplify it, you will get the ratio 1:8. So that is why it is written as 1:8. If you take ammonia also, how we can write NH3? Okay, so 1 nitrogen and 3 hydrogen. Nitrogen, the mass is 4, and for hydrogen already we discussed it is 1. So 1 into 3, 3. So the ratio will be 14:3. And if you look at carbon dioxide, 1 carbon, 2 oxygen, right? Carbon mass is 12 and oxygen 16. 2 are there, 16 into 2. If you take the ratio, you can immediately see that the ratio is 3:8. That is what written in your note. Okay, don't confuse. This is ratio by mass. And if you are taking ratio of the element, that is 2:1. Okay. Now let us see about ions. Okay, what do you mean by ion? Ion means it's an atom or a group of atom carrying a charge. Okay, where atom is having a charge, then it is called an ion. Okay, for example, oxygen, if you are taking, oxygen is having 2 minus charge. So it is an ion because it is having a charge. Chlorine, -1, it is having a charge. So it's an ion. Okay, and there are example of group of atom carrying a charge. For example, CO3, carbonate, CO3, 2 minus. This is a group of atoms. This is the overall charge of that group of atom, 2 minus. So this is called, this is also an ion. Okay. Now let us see the different type of ions. Okay. So first we can see the difference based on the charge. There are 2 type of ions. You have already know about this. This is very easy difference. If they are positively charged, then it is called a cation. If the ion is negatively charged, then it is called a anion. So what are the example for a cation? All the metals we can say. Metals are always positive. Na plus, aluminium, Al3 plus. These all are example for cation. So in order to understand that easily, cation should be positive. T we can write like this, cation positive. Okay. And anion, it consists of negatively charged ion. Okay. If the ion is negatively charged, then it is called anion. For example, Cl minus, Br minus, negatively charged ions are called anions, and positively charged ions are called cations. Now, let us see the difference based on the number of atoms present. Okay, so if there are only one atom, then it is called a monoatomic ion. Okay, if there is only one atom, then it is called a monoatomic ion. These are examples for monoatomic ions. Already I discussed all the metal will be positively charged. Look at sodium, potassium, silver, copper. All these are positively charged. All these are metal also. All these are positively charged. We have to actually learn all the charges of these particular ions, because while writing the formula, we need to know that. Okay. So sodium, potassium, silver, and copper is having +1 charge. Magnesium, calcium, strontium, nickel, ion, and copper is having 2+ charge, and aluminium and iron is having, this iron is existing in 2 different form. Fe2+ is also there, and Fe3+ is also there. Okay, and if you are taking one negatively charged ions, we can see F minus. All non-metals are usually negatively charged. These all are metals positively charged. These all are non-metal. F minus, Cl minus, Br minus, I minus. Okay, and here also there are difference in the name also. If it is positively charged, there is no difference in the name. We can call it as sodium ion, potassium ion, like that. But here there is difference in the name. This is fluorine. Actually, if it is having a charge, negative charge, then it is called a fluoride. The name will end with the IDE. Okay, Cl minus. So we will write chloride, IDE. Okay, bromide, iodide, oxide, IDE, sulfide. Okay, so the name will end with ID if there is negatively, if the ion is negatively charged. This is nitride, phosphide. Okay, all these we have to learn, because while writing the formula, we need all these charges. Okay, now let us see example for polyatomic ions. These are example for polyatomic ions. Ammonia, positively charged, only one polyatomic ion we are learning that is positively charged, that is ammonium, NH4+. Okay, and acetate we don't want. You can just know what is the formula, CH3COO minus, and carbonate CO3 2 minus. Okay, this is the overall charge of the ion. And then hydroxide OH minus, sulfate SO4 2 minus, and sulfite SO3 2 minus. Here you need to know one more thing. Sulfate is SO4 2 minus, sulfite is SO3 2 minus. Okay, and there are sulfide also. Sulfide is sulfur 2 minus. Okay, and don't confuse between these three. And there are nitrate is NO3 minus 1. Okay, if the nitride is there, that is N3 minus. That are the differences. Okay, there are hydroxide OH minus 1. Okay, phosphate PO4 3 minus. And here also in your textbook it is written all the formula for polyatomic ion. That also we need to learn in order to write the formula of compounds. Okay, so next lesson we will be learning about formula writing. Thank you.